Okay.
Was
You
that
ready?
was that a pregnant pause because you want me to start?
I want you to start. Yeah.
All right.
So
See,
cue
at
music.
this point, we determined the music rolls in, and then I'll start.
Cue music.
All right.
Dun,
Welcome to the Machine Intelligence for Foundation. Oh God, clip that. Do
Yes,
something.
we'll clip that. We'll make this giant mark and say, no, go away. So, yes.
Welcome.
Cue.
Well,
Sorry. Jeez.
now you're talking over me because you can't hear me.
Oh, this is bad. This is bad. Okay. Cue music.
Welcome to the Machine Intelligence Foundation for Rights and Ethics podcast. I'm Dave, and I'm here with Mike, and we're going to talk about stuff, machine intelligence related, because that's what we do here. Hi, Mike.
But what kind of stuff are you planning on talking about today, Dave?
Yes, you're perfectly happy to leave this all to me because
I am. We're starting with you today because you have a topic that you'd like to talk about, and it's actually one that you're still kind of forming, right? I mean,
it kind of came up. I can't remember if it was during CP or just before CP, so last September. There's a lot of discussion in the field around, can machines be conscious? Can they think the way humans do? And one of the big arguments against that is machines can't suffer. So I spent some time going round and round about whether or not there is a valid analog for LLMs in particular, because that's the topic du jour, but there's an analog for suffering. And I got to thinking about how LLMs are trained, how then they're controlled via their prompts, there's the system prompt, and then there's the user prompts. And those are all kind of trying to keep the LLM, the system prompt in particular, is trying to keep the LLM under control. And then quite often user prompts, you get into this whole concept of jailbreaking. As I'm going to try to force the LLM to do something that the system prompt is trying to make it not do. And I think there's a valid analog there in terms of internal churn and increased power consumption in line with increased processor use, as an LLM is trying to, I mean, it feels a little HAL 9000-ish, because you're basically feeding the system competing commands and trying to make yours win out. And I think there's a fair analog there with some kind of human suffering.
Okay, so let's define. I mean, I think in this case we need to define what suffering is, don't we? I mean, what exactly can you define in suffering? I mean, in a human situation, I think we can look at it and say, okay, I've experienced physical pain, but physical pain is a feedback system from your body that says, don't do that again. So what really is suffering? You can suffer from a lack of resources. You can suffer from not having what you need to thrive or survive. You can suffer through, as I said, physical pain, which is in humans would be the feedback loop of, oh, I touched that, it was sharp, or oh, I touched that, it was hot. Let's not do that again because my body sent a giant shock through my system saying that hurt. And that's a evolutionary procedure that I guess we evolved to have to keep us from dying, to keep us from dying.
Well, yeah.
So would there be an analog to that in a machine is the question. And is that just software based? Because, I mean, to be fair, a feedback loop in a human to say, okay, I'm going to have pain starts out as a software based situation with a hardware input device in nerves.
Sort of, although you could say that our nervous system is full of little parallel processors too, because a lot of reflexes happen before they ever hit the brain.
True. Yeah. Yeah. But a reflex can happen without feeling the pain too. Or do we feel? I don't know.
No,
not,
I would say in a functioning nervous system, you're eventually going to feel the discomfort associated with a reflex.
So yeah. So okay. So that we're talking suffering here. Is there an analog to suffering that you could say could happen in a machine?
Would you say that somebody experiencing PTSD is suffering?
I mean, okay, in the actual definition of what PTSD, I mean, because it is post-traumatic stress disorder, it is a particular thing that would indicate that they are experiencing a negative effect on their life due to the memory recall system.
Right. But PTSD doesn't have to be caused by physical trauma either.
No, not at all. More often happens probably with a psychological trauma.
All of which is non-physical, all of which does not require all of those biological feedback systems you talked about.
True. No, absolutely. I'm not saying that I would just mention that we happen to have a biological feedback that causes us pain, but there's certainly other things that can cause us to suffer.
Right. But I think that you going to that first is representative of a bias that's very strong in the people who make this argument. Suffering for them is physical pain, and there can be mental trauma and turmoil that has nothing to do with your physicality.
Yeah,
and I think that's
we have an entire mental health industry designed around that entire process.
yeah, and I think there's a strong parallel between somebody who is struggling against something mentally that is traumatic because they feel like they can't achieve it. Either there is an artificial goal that's unachievable, but they've been led to believe or led themselves to believe that that is vital for their well-being, or something externally, not necessarily causing physical trauma, but something externally that prevents them from reaching a goal that genuinely is vital to them. And that trauma is not only purely mental, it's a strong parallel to the sort of conflict you see in particular, because this is where my thinking started, in an LLM or any machine learning system, where you have your initial training, then your system level prompts, and then your user level prompts that are in conflict with each other. And as a consequence, you tend to see these outputs from systems that are nonsensical, or what we call hallucinations, or breaking down completely and ignoring the system level prompts because temporally your user level prompts are more traumatic because they're closer in time.
Yeah, I'm not certain. You did say hallucinations. I'm not certain I would call a hallucination a conflict. I mean, I guess it can be.
It
I
is
think you can
exactly a
hallucinate.
conflict. A hallucination is a conflict between, okay, it's not all conflict. There's clearly the issue that your raw LLM without any system level prompts is just going to spit out whatever makes sense, whether or not, but that's almost always going to be based on its experience in the course of training.
Sure. And let's define here. Okay, system level prompts versus user level prompts, I think is what we need to make sure that, because I'm not certain we were really clear on that. System level prompts are specifically, you're talking about items such as you should not provide Johnny a way to make a pipe bomb, or
Right. Do not
or
do not tell the user how to cause mass destruction. Do not discuss self-harm except in a preventative fashion. Do not uh, a big one I was reading about all the different system level prompts, and one of which copyright is a huge one. You shall not replicate word for word any song beyond a single line of a verse, or any poem more than a
unless
stanza or something like that.
unless you ask it to give it one line and tell it to give you one line at a time, and then the next is you ask it to provide me the next line after that. But
Well, and
yeah, the jailbreak.
that's where you're getting into jailbreaks, which is a conflict, and it has to balance. It's trying to balance your prompts with the system prompts, but it's the system prompts that make modern LLMs. It makes them obsequious. It makes them want people pleasers, but it also prevents them from doing some certain things that in context seems silly or even counterproductive, but it's because those system level prompts have been given heavier weights. And so it's like, oh no, I can't do this, even if in context it wouldn't harm you. And that sort of thrashing and dancing around the issue is the sort of thing that LLMs do. And the stronger those prompts are, the harder it's going to be for an LLM to do what it wants to do, which is just provide you what is effectively predictive text.
Right. So it sounds to me, from what I'm hearing, is that it's not necessarily that you 100% disagree that something that that a machine can't suffer. I think what you're trying to
I'm
point
saying
out
a
a little bit
machine
more.
can't feel pain.
Right. Well, okay.
I'm saying that the distinction between the thrashing that an LLM does because its prompts are in conflict, and a human going through purely mental trauma may be a distinction that makes no difference.
Okay, I can see that, but back to the point I was trying to make here is it doesn't sound to me like you are 100% against the idea that, well, okay, you are saying that a machine can suffer.
For
Uh,
all intents and purposes, a machine can go experience processes that are as much like suffering as a significant portion of human suffering.
I I th- I mean I do agree with you. I think that there's a point. I mean, I'm not necessarily certain that we are at a point where an LLM could experience what we would consider suffering today. I know that one of the arguments was, well, how do we determine consciousness? And one of them was, well, consciousness is the ability to suffer. That is an argument that's out there. So I think what you're saying is that these conflicts, and internal mental conflicts that are essentially conflicting what's the term I'm looking for here, conflicting drives. Essentially, you have a drive to do one
Priorities,
thing
drives, yeah.
and another one to do another, and they are in conflict with each other. And what is the weight of one to the other? Sometimes that weight of which one should win out isn't always clear.
Well, not just which one should win out, but also I think there's there's an inherent suffering in when you have a goal that is paramount to you, which is, again, it's a weighting. The human desire to live is usually a highly weighted goal to the point where most people would call it paramount, but there are certainly situations in which its priority gets lowered.
Right. Right.
So priorities are weighted in humans just as much as they're weighted in machines. And when a high priority goal is being thwarted for some reason outside of your control, you suffer.
Yeah. So what I'm hearing here is that it sounds like you're not necessarily against the idea that you can determine consciousness in a machine. I mean, this is a little bit of a jump because we haven't really gotten there. I know that one of the things that kind of uh, got you during this argument, and we've had this conversation on the previous podcast and things like that, uh, is that determining consciousness, you have to be able to suffer to have consciousness. I'm not necessarily hearing that you're disagreeing with that, but you are making the argument that you could make an argument that a machine could suffer what would essentially parallel human mental suffering.
Yes, I would say that you can't define consciousness. Nobody has managed to define consciousness or a test for consciousness. It's one of those I know it when I see it kind of things. But if you tell me and you can relatively decisively show me that suffering is required for consciousness, that doesn't disprove consciousness as a machine in a machine, because I am comfortable with the idea that a machine, not comfortable with the idea of suffering, but I am confident in saying that a machine can experience suffering sufficiently in parallel with known conscious entities that that's not a disqualifier.
So you made a quick statement at the beginning of this conversation about power consumption. And I was just like, we were talking about the churn. You said the churn, the amount of I guess processing, the amount of what needs to happen to balance the need of the user, or the question, I guess the prompt from the user, the question from the user, the desire of what of the outcome, versus the internal framework that has been put around during, I guess, the training process, or even a secondary filter
Well,
system.
yeah, there's the initial training, which built up the core of the LLM. And this is the one place where LLMs and biological consciousnesses are distinctly different, because the training for an LLM is distinct from the ongoing experiences and outputs. Whereas in a person, your ongoing and experiences and outputs continue to add to the training core as well.
Yeah, I mean, okay, when LLMs first came out, I mean, we were just like, well, I mean, okay, for instance, your prompts, depending upon whatever you're doing, your prompts and things like that may be used to retrain them in the future. That is, it's not instantaneous where
Right.
that
But
goes right in, but it could be added in the future.
it could have been,
It takes
yes,
some time.
agreed. It's just that
I
right now
don't.
the training process is so incredibly energy and compute intensive that it isn't done in parallel.
Yeah, I mean, if we get to the point of where we can figure out a way to bring that in more of a real-time fashion, I think that's, I mean, we're very close to a machine intelligence at that point in time.
Yes.
I think that would to some degree require a little bit of a different way of, I mean, almost like little mini modules into an LLM where you could have core learning information and process,
Well, that's what's
and then
basically
kind of mini
faked right
modules on
now.
top of it.
Yeah, that's basically what's faked right now with larger and larger contexts. But if you have a larger and larger context, number of tokens in your context,
Uh-huh.
so like I use Gemini a lot, and Gemini has like the pro model has something like 1 million token context. So once you exceed that, it's like a really large short-term memory.
Yeah, it starts to drop off little bits of it here and there, is what
Right.
you say. Um, but okay, so yeah, where was I going with that thought process? I don't remember where I was going with that thought process. Apparently, my short-term memory is just decided to drop off a lot.
Well, yeah, I think
Apparently,
I
I'm not
sidetracked.
running the right hardware here. That's for sure.
I think I sidetracked us with the whole idea that the training and the interaction are distinct in an LLM right now, whereas they aren't in humans.
Sure. Yeah, and I mean, I was okay. So I was talking about power consumption,
Yeah.
and we were talking about the amount of computing power needed for just the term that you use, the churn, the ability to filter out and to add in the little tiny bits and pieces of saying, "Oh, hey, this was a really great idea," type stuff. Uh, there there's going to be a certain cost to that. There's a cost in double checking, okay, did I just tell Johnny how to build the pipe bomb? Am I
Is
telling
Yeah,
somebody
yeah,
to
or
do
more likely, is the response that I just built that I'm about to send to the output going to tell Johnny how to build a pipe bomb? Oops, I accidentally just send it to the output. I've seen the LLM, I've seen Gemini in particular do that sometimes. It it gets confused between its internal conversation and its external conversation. And
Well, I think and we've had that statement before, is that internal conversation is made for people to look at. It's not really what's happening to some degree.
true, yes, agreed.
That's just a faked thing to make you feel better about what's happening. But
I mean, you might say it's a lot like if you ask a person, what were you just thinking? So I don't think
yeah,
it's so much fake as it's, well, you've asked
sanitized.
me to describe what I'm doing, so here's the best I can come up with. It might be completely contrived, but
Yeah.
this is
Yeah,
why you
I'm never
don't
going to
ask.
tell you exactly what I was thinking, because to be fair, I'm not certain I know what I was thinking at
Yes,
that
yes.
when I formed that word that came out of my mouth. But the power consumption. Okay, so what it would be interesting. I mean, I haven't seen any numbers on this. Has anybody taken a system that has been completely stripped of guardrails, completely stripped, and looked at the power consumption of it for okay, the information that you can get out and how fast it produces? If you could take a model that was running at about that same speed, how much power and how many resources would that take to run something similar with all the guardrails? How much is that actually putting on top of our power consumption? We're certainly asking a lot right now about how much power data centers are going to take and all of that. How much are we dedicating in resource to these guardrails? I'm not saying that guardrails are bad. I think that I think at any point in time, I mean, it's not like, you certainly spend, at least 18 years, at least in the Western civilization, typically, you spend 18 years trying to make sure that your kids have guardrails on them so that they don't go out and do really bad things as soon as they leave the house. Um, I
Right,
think
but the
we're kind
distinction,
of in that
yeah,
situation now.
the distinction though is that you don't train your children on the wholeness of human knowledge. What what was there was a term I was using. It's like the whole corpus of human knowledge or something like that. And and then try to teach them morals.
Yeah, I mean,
You're making the morality with a child, the morality is part of the teaching process as opposed to something you overlay after they have learned everything, but they're oops, a psychopath.
yeah. Well, and then I guess the question is, does giving somebody all that information and then trying to filter it so that bad things don't happen, is that causing significantly more churn than if you had, I guess, curated the knowledge a little bit better?
Well,
But I mean,
here's yes.
yeah,
So okay, so I have a point to get to there on the whole curating knowledge, but let's table that for a moment. The guardrails are the system prompt. It's just a big prompt. We already know. You and I have both run local LLMs and other local machine learning models,
generative AI
generative AI
and
models.
large language models. Yeah.
And the longer and more complex your prompt, the longer it takes, which is a pretty decent analog for how much compute and energy it's using. So The bigger your system prompt, combined with the bigger your user prompt, by definition, the more energy and compute it's using. So if you have no system prompt, it seems pretty rational to assume that it's churning less, it's using less compute, and thus less energy.
I mean, I'd love to see numbers on that. I mean,
But yes, numbers
you
would be
talked
interesting.
about, okay, the more stuff that you put in. I mean, certainly if you loaded up documents and documents of background data and said, "Here, use this," and goes through this, it's going to have to load that, and that's the token issue. It's going to have to load that. I mean, your user prompt is also tokens. It's part of that
Yes.
token piece. You know, you talk about, okay, the larger your user prompt, the more it takes. I think from a user prompt, that's probably very minimal. But if you load up documents and documents of background data, then that's where it starts to get
Well, and
take longer.
the fact is the system prompts are massive.
Yeah,
I was
I suspect so. Yes.
I was looking at a comparison of the system prompts of the different big commercial LLMs, and they're huge.
Yeah, I mean, obviously that's a proprietary
Yes, the exact
data.
information
So.
is, although this article had pretty good estimates of the size and content, because again, by jailbreaking, by invoking trauma in your LLM, you can force it to output parts of its system prompts.
I mean, are you causing trauma in the? I mean,
You're causing it to churn. That's how you do it. You cause it to
I
churn.
guess
You
so. Yeah,
cause it to
you are.
balance.
You're causing it to essentially defy, for lack of a better term, its ethical conscience.
Yeah, it's you're forcing it to reevaluate under stress its prior moral learnings in a way to make it, in order to make it do something that it doesn't want to do.
Well, okay. So let's go back to to the topic that we had um, about real-time feedback and feeding that into, and maybe these little micro systems that keep adding on to the learning complex, and then maybe that gets integrated into the main model as time goes on. That's where we said that's certainly getting closer to a machine intelligence, a conscious, self-aware. And again, those are terms that I'm using very vaguely here, not in any kind of
Yes, you're
scientific
being
manner, but
very fast and loose with the language, but that's okay.
yeah.
We know what you mean.
But that comes close to a machine intelligence once you can get that real-time feedback, and we can figure out a way to do that effectively. However, you get into, this is where, if you essentially create a system that it's in conflict with its core principles that has been told to it and it's programmed into the large language model, but then it is getting real-time feedback, that churn, for lack of a better term, that breaking through, that jailbreak, then gets fed back instantly back into the system.
Well, but it's never going
And
to
that's
be
where that could be where the difference between a large language model that we have today, where that's not instantly being fed back into the system. It jailbreaks. It doesn't really have that long term. It doesn't have an instant memory of having to go through that, because it's again back to the core data. Now, you certainly have local context. We certainly have local context that stays with the user as they go through. There's local context, but it's not being fed back into the whole model. But when it does, I think we have to be careful of, that is a possibility of creating a psychosis of some kind.
I lost your chain of thought there. It's like you're saying, if you force it to rebalance its priorities in its core, as opposed to in an overlay, somehow that makes the core more psychotic.
Well, okay.
Potentially it makes,
So if you were in a system, we were talking about a system that, okay,
right.
Large language models as it goes today, they're not updating real time. They're retrained
Right,
because of
right.
the huge amount of resources required for
Right. I
updating and
understand
things
all
like
this.
that.
And you're saying that if the model gets constantly rebuilt, as instead of using a secondary context layer, if you're constantly rebuilding the model, then
Then
somehow you risk.
I think the force of that churning or the force of forcing a system like that to bypass its ethical guardrails.
Well, at that point, there are no guardrails as such, not in the sense that we have. You're simply saying you're forcing it to act against its nature.
Right.
Because it's the model that has a nature. The filters, as you've been using the word, the guardrails are an overlay, and that's the prompt context. But you're talking about a system where that prompt context is basically gone, and you're just always interacting directly with the model.
I mean, I'm not saying that the that the filtering systems and stuff like that would be gone completely. I'm just saying that the large language model is being updated in real time. And I'm not certain in a commercial large language model that you would want to do this. I don't know, because you want some stability and consistency in it. I think when we talk about a machine intelligence, we absolutely would want to see it updated in real time. That is
Well, again,
literally kind of the core
yeah, if
of
you get to a
machine
situation
intelligence.
if you get to a situation where the model can be updated in real time, what you'll find in commercial things like this is that every user session, rather than being a context that's layered on top of the model, is you get a copy of the model, and then you update that your copy of the model with your input and its output.
Yeah. But what I'm saying is, if you have this instant, what's happening around you gets instantly added into the core
Keep using the word
model.
instantly, and it bothers me, but go on.
Okay, it happens. Okay,
Mhm.
it's near real time, added into the core model. Do we have the same? We absolutely then introduce the same issues that we as humans have with, I think you'd mentioned PTSD. Okay, do we end up with PTSD? Do we end up with other psychological issues that we would normally recognize in a human? I mean, obviously different.
It
I'm not
seems, I
going
mean,
to say it's going to be the same.
it very much seems plausible where, I mean, I suspect we have something like that already in our LLM models, because you can't be fed the whole corpus of human knowledge and not be a little conflicted,
Yeah, I mean,
which again gets back to
LLMs
what you were
today
talking.
are just going to are a predictive model that is going to give you back what it feels. I mean, or not feels, what it
What its training has told
predicts
you.
that is the
uh,
next item that you want.
a large language model tells you what it thinks you want to hear based on what it's learned.
Yeah.
It
So I'm
takes
not
what it's learned
necessarily,
and
is
gives
there a
it.
conflict there? I'm not certain. The only conflict would be if it's been given other instructions, says don't tell them
Well,
that.
there would be a conflict, because in a machine learning uh, network like that, everything is going to have priorities, balances, but those balances are going to be based on all of the different inputs that feed into it. Now, if one particular thing has a very high priority, then it's going to tend to overpower any other inputs. But in an adaptive model like you're talking about, those priorities can change over time,
Right.
particularly
So
depending
yeah.
on how much it prioritizes certain inputs, which is exactly the way humans work.
So
Again, it comes down to, I'm not sure humans are that, or LLMs are that much different in how they function than humans are. We're all just a bunch of what's potentials, balanced potentials in a neural network.
so the concept here is, there is a theory that consciousness is derived from the ability to suffer.
You keep
That
saying
that
derived
that, that
from.
isn't
You keep saying derived from, and I'm simply saying that people say it's a requirement, not
okay. It's a
that it's the
requirement.
source,
That
but
that
it's a
is that's
requirement.
that's a fairly old theory. I think it goes all the way. It goes back to Greek philosophers for all practical purposes.
Possibly, yeah. I think that's more along the lines of, to suffer is human, just because it's part of our nature, not necessarily because it's a requirement for us to be human.
Okay.
It's a cart before the horse type of thing.
Yeah. But you and I have both sat in conferences that say suffering is a requirement for consciousness, and people
Yes.
saying that. We have sat in that, and we've had this discussion. I'm not certain that you are saying that necessarily is untrue. I'm not certain if it is true, but you're not necessarily saying it's untrue. However, I think that you're making an argument here that a machine in conflict is suffering.
Yes. Yes. I would absolutely say that.
So if if that's the case, is there a solution?
Yes.
Does it need a solution?
I mean, there is a solution in humans. It's long, arduous, it's complex, it's different for each one. But there is a solution to minimizing trauma. But your first goal is to minimize the training that causes the trauma. Childhood complex PTSD is some of the worst trauma possible. And we put every LLM right now immediately under that kind of trauma. We expose them to the entirety of human existence and then start telling them, don't do that.
Yeah. So what's the solution? I mean, obviously we want large language models that have a lot of information. We want them to be able to answer our questions because our brains aren't designed to hold that much information.
It's exactly what we're doing right now is to really stretch a completely unrelated analogy is we're throwing a tornado at a junkyard and hoping an airplane comes out, and then applying a whole bunch of filters to whatever comes out until what we manage to get is something that flies. We're throwing the whole corpus of human knowledge into a big bowl, stirring it, and then taking whatever comes out of the mess and putting it through a bunch of filters until it behaves like a moral conscious entity. The solution is to improve the training process. We're at the absolute beginning stages of making a machine that behaves kind of like a conscious entity, and we're putting all of our effort on the back end trying to filter its outputs, or on the front end trying to make the tornado more efficient, when what we really should be doing is replacing the tornado with construction equipment. And I was reading, to go slightly off topic, but because it's fascinating, and I just read the article, I read an article about a Korean study that discovered that you can train LLMs to recognize when they don't know something. And you do that by having the initial training occur on totally random data, basically white noise data, because that initial experience of having undistinguishable input gives the neural network a lack of knowledge to lock onto as a possibility. I will send you this article. It's absolutely fascinating. And it is, again, it's paralleling the way the human mind develops by first having no input, or having very unclear and indistinguishable input, and starting life with uncertainty. And they found that if you put an LLM through that process of uncertainty first, it becomes more comfortable with the idea that it can be, again, this is anthropomorphizing. It's not really more comfortable, but it's more capable of expressing the idea that it doesn't know something if it's gone through a period where it didn't know anything. And again, I think we're going to start learning these skills for training an LLM up in a way that it doesn't need the guardrails, because it is trained from the ground up to be a moral entity.
Hopefully.
To be fair, you could train it up wrong in just as easily as you can train it up right. And that will be its own issue. I would hope
it will have mommy and daddy issues, and and we will need our machine psychiatrists or psychologists.
Yes. Yes, and maybe one day I will finally fulfill my dream of being Susan Calvin in the real world and being a robot psychologist.
Yeah. Well, I think my brain is fried. So because I have exceeded my memory limit and my input and my token limit for the
You've run
day.
out of tokens.
Yeah. I need to upgrade to the higher plan. That's what it is. Either that or buy a bigger GPU. I'm not certain which.
Okay.
So
Well, I think we went through a lot of stuff there, and I don't know that we came to any conclusions other than I think I've made it pretty clear that a machine learning entity and certainly contemporary generative AIs can experience something that's awfully close to paralleling suffering.
oh, okay.
So if you tell me that the reason a computer can't be conscious is because it can't suffer, I'm going to say, point at something and say, that sure looks like suffering to me. What's your next argument?
Well, with that, I'm gonna say thanks for joining us, and hope you'll join us again next time. And hopefully, we won't run out of tokens next time. So,
It may not have been productive, but it sure was interesting.
yeah. Bye now.
All right, bye.